interested in how plausible the scientific explanation is for the world in which we live, check out the harvest moon. I think it's on the 6th of September, but it's going to be between 8 and 10 times bigger than what it normally is. There's £1,000, Mark Taylor. Solar eclipses happen every single month, and it's caused by the orbit of the moon going around the Earth. I bet you £1,000 solar eclipses happen every single month. The issue is we never see them because they're normally over the Earth, normally over the water.
However, as I say, there are examples of it that can be obtained from the ground, with the same effect of a virtual horizon being lower than the actual horizon. This is something I have done. There is an example, not a great one, admittedly, filmed on a camera phone, very shaky footage, but of exactly that, the sun setting on the actual horizon, regardless of where the land is. I mean, I intend to get this in a much better quality, because for me it's a flat earth proof. If the sun is going around the earth, the topology is what blocks the sun. In other words, what I am calling the virtual horizon would absolutely be the thing that the sun sets behind. And because the lay of the land is lower than the actual horizon, the sun sets mid-air.
Yeah, but what the point I was making was that if Fermat's principle about taking the least amount of time involves taking the path of least resistance rather than going through the more denser stuff, that implies that it will bend to avoid the more denser stuff, taking the path of least resistance. But Snell's law doesn't give the choice. Snell's law says if it goes into the medium, it will slow down, indicating that Fermat's principle isn't right, because Fermat's principle indicates that it's taking the path of least resistance. No, it's not, because the angular size of an object is determined by its actual size and its distance, which we do not know. We don't know either of them. So all you're doing is measuring the size. That's the angle size, not the angular size. This is right. I've just typed in paramagnetic fluid in YouTube to see what comes up. So what this is showing is that a magnet can influence liquids. Yes. And if there's salt in the liquid, it will create movement. And what my assertion is that what we are seeing with the tidal map, what's it called, the amphibian, the amphidromic point, is showing that the tidal points are nodal and they are not uniform across the Earth.
In this video, we're going to demonstrate paramagnetic fluid. It's ferrofluid's weaker and less famous cousin. However, it does possess the property of being transparent, which almost all ferrofluid lacks. It's also somewhat easier to make. First, we need a paramagnetic salt. Now, I showed in a previous video that dysprosium nitrate was paramagnetic, but there is a cheaper and easier to obtain paramagnetic salt, manganese nitrate. The attraction is very weak, but it's there.
And these people consider themselves educated, smart.
Yeah.
It's like you cannot use critical thinking if you're literally going to go to a maths equation and quote what it says to me as though it's reality and think it's correct. And when I pointed this out to both of them, they both ignored it. Literally had no response to their idiocy.
It was exactly the same. He was like, well, you've changed it now. What's the problem? And I'm like, well, look at what he's saying. This is why ball earthers can't call out ball earthers, because they can't critically think about their own ball earthers nonsense. They just accept it. Now, they think that they call out their ball earthers nonsense because Gio claims that he's called Sean out for this and Rumpus out for that. But there's glaringly obvious mistakes and problems in this nonsense.
Chat now, Nick, Nathan Oakley, go on the Metabunk site right now, change your viewer height and observe whether or not the drop changes. Yeah, the maths might say the drop doesn't change, Nick. Is that what you accept as your basis of reality, you complete idiot? Oh my God.